This LOS is identify the factors that determine the value of an option and explain how each factor affects the value of an option. Okay, we'll just start with a quick review. This is something that we've seen before. Here's just some nomenclature for the calls and for the puts. For the European calls, we've got the small c naught is the value of the price of the European call today. Small CT is the value of the price of the European call at expiration, and this is what we're looking at. When the call is at expiration, the value is the maximum of 0 or the underlying price at expiration minus the exercise price. So with a call, it gives you the right but not the obligation to buy something. Buy low, sell high. So we want the exercise price at expiration to be more. So again, a quick example, if I've got the right but not the obligation to buy at 100 euros and the stock is at 105, then I'm in the money, I will exercise. Because the underlying price at expiration, 105, minus the 100, I have a positive value of 5, okay? Moving on to the puts, the small p naught is the value of the price of the European today, and small pt is the value price of the European put at expiration. Again, that's what we're looking at here. And at expiration, the value is the maximum of 0, but in this case, we want the exercise price minus the price at expiration. So don't forget with the puts, it gives me the right but not the obligation to sell. So I want to sell high and buy low, okay? So again, if the exercise price is 100 and the underlying price at expiration is 95, which is below, it's going to be in the money, I'm going to have a profit of 5, okay? So that's just a quick review, but now we're going to look at what are some of the effects on the value of the options, okay? So starting with some of the effects on the value of the options, the first thing is the value of the underlying. So the value of the underlying is obviously a critical element in determining the value of an option. It is the uncertainty of the underlying that provides the motivation for using options. It is easy to rationalize the direction of the effect of the underlying. So a call option can be viewed as a mean of acquiring the underlying, whereas a put option can be viewed as a means of selling the underlying. Thus, a call option is logically worth more if the underlying is worth more, and a put option is logically worth more if the underlying is worth less, okay? So the value of the underlying also forms one of the boundaries for calls. The value of a call option cannot exceed the value of the underlying. After all, a call option is only a means of acquiring the underlying. It can never give the holder more benefit than the underlying. Hence, the value of the underlying forms an upper boundary on what a call is worth. The underlying does not provide an upper or lower boundary for puts. That role is played by the exercise price, as we'll see in the next section. So the value of a European call is directly related to the value of the underlying, and the value of a European put option is inversely related to the value of the underlying. So now we're going to look at the effect of the exercise price. And so the exercise value of European call, again, that's the maximum of 0, or the underlying price at expiration minus the exercise price. So the call is in the money if the underlying price at expiration is above the exercise price, because we want exercise buy low, sell high, okay? And is out of the money if the underlying price at expiration is above the exercise price. So the value of a European call option is inversely related to the exercise price. And these are the sentences that you need to pick up for multiple choice examples, questions that are most likely or least likely, okay? Now moving on to the exercise value of a European put, we know that the value at expiration is the maximum of 0, or the exercise price minus the underlying price at expiration. We want to sell high and buy low, so we want the exercise price to be above the underlying price at expiration. So the put is in the money if the underlying price at expiration is below the exercise price, and the put is out of the money if the underlying price at expiration is above the exercise price. So the value of a European put option is directly related to the exercise price. And intrinsic or exercise value is the amount in the money. And as we've seen before, and we'll see it again, that the option price is the intrinsic value plus the time value. Now we're moving on to the effect of time to expiration. The value of a European call option is directly related to the time to expiration. So the longer time that you have until expiration, the higher probability that the option will be exercised. So there's a value to time, okay? You have longer for the situation to arise. Now the value of a European put option can be either directly or inversely related to the time to expiration. The direct effect is more common, but the inverse effect can prevail. With a put, the longer the time to expiration, the higher the risk-free rate, and the deeper it is in the money. So anytime you see some exceptions like that, that's good material for exam questions. Now we're moving on to the effect of the risk-free rate of interest, and the value of a European call is directly related to the risk-free interest rate, and the value of a European put is inversely related to the risk-free interest rate. So you see I put those words in green and red because this is the memorization that you need to do. And if you look at the effect of volatility of the underlying, the value of a European call is directly related to the value of the underlying, and the value of a European put is also directly related to the volatility of the underlying. Higher volatility means higher probability of the exercise being being exercised, the option being exercised, and that's why volatility is directly related to both the value of the call and the put. Okay, I'm going to start with a practice question that we've seen before previously in the fixed income when we were talking about callable bonds. And this is why I said that as you go through the CFA curriculum and then recycle back and review, sometimes it gets a little bit easier because sometimes some concepts are coming up, in this case with regards to a callable bond, and you haven't fully covered the material. So this is a question we've seen before. I said you go back to it and you'll say, okay, I've learned something now in derivatives that's applying back to the fixed income with regards to the callable bonds. It's starting to make a lot more sense to me. And that's why I always say to candidates, you need to have patience, patience, patience. It's 300 hours of studying. You know, don't get stressed out until you're through the material once and go back and start to review. It gets easier on every pass. So this is a perfect example of that, okay? So when interest rates fall, the price of a callable bond will A, fall less than an option-free bond, rise less than an option-free bond, or C, rise more than an option-free bond. You see, aha, now we're starting to get it, because in this reading for the derivatives, we're now learning that the value of a European call is directly related to the risk-free interest rate, okay? So therefore, B is correct, because when interest rates fall, the price of the embedded call option increases because the call option is directly related. And since the price of a callable bond is the price of an option-free bond minus the price of the embedded call option, because the issuer has the right to call the bond, so they're paying the bondholder for that right, the price of the callable bond is the price of the option-free bond less the price of the embedded call option, and that call option is going to go up when interest rates fall, okay? So the price of the callable bond will not increase as much as an option-free bond since the price of the call option is increasing. As interest rates fall, the bond is more likely to be called, limiting the upside price increase potential. So recall the issuer has the right to call, so they have paid the investor a premium for that right, which lowers the cost of the bond versus an option-free bond. Now again, we're studying derivatives right now, and I took this question from the fixed income, and now hopefully it makes a lot more sense. Once we saw that for the first time back in the fixed income, of course, we're learning about callable bonds, but we didn't learn about the the effective interest rates on options. So, we hadn't covered that yet. Now we have covered it. You go back, recycle the material, it becomes a lot easier, trust me. So another quick practice question. As I said, you just got to memorize these rules and get them straight. If the risk-free rate increases, the value of an in-the-money European put option will most likely A, decrease, B, remain the same, or C, increase. So recall the rule from the previous slide, the value of a European put is inversely related to the risk-free interest rate. Therefore, as interest rates increase, the value of an in-the-money European put option will most likely A, decrease. An in-the-money European put option decreases in value with an increase in the risk-free rate. A higher risk-free rate reduces the present value of any proceeds received on exercise. Another nice quick practice question. These do not take 90 seconds, but you see there's a lot of memorization for CFA Level 1 with regards to rules and definitions. So the value of a European call option is inversely related to A, exercise price, B, time to expiration, or C, volatility of the underlying. Again, you can see this is pure out memorization. So recall in the previous slide, we're talking about the exercise value of European call, and the call is in the money if the underlying is greater than the exercise price at expiration. So the value of European call option is inversely related to the exercise price. Therefore, A is correct. The value of European call option is inversely related to the exercise price. Time to expiration? No, we know the longer the time, that's a positive correlation. And volatility of the underlying, that's a positively related as well for both the calls and the puts, recall. So A is correct. The value of a European call option is inversely related to the exercise price. A lower exercise price means that there are more potential outcomes at which the call expires in the money. The option value will be greater the lower the exercise price. For a higher exercise price, the opposite is true. Both the time to expiration and the volatility of the underlying are directly positively related to the value of European call option. Okay, so we got to memorize these rules. It's not too difficult. Write it out, throw it away, write it out, throw it away. Make your own little cue cards, flashcards. Just got to memorize all these relationships. So just two more practice questions and we'll finish this LOS with one last slide after that. First practice question, which statement best describes option price sensitivities? The value of A, call option increases as interest rates rise. B, put option increases as volatility decreases. Or C, put option decreases as interest rates decline. Again, just reviewing the rules here. So which statement best describes option price sensitivities? The value of a call option increases as interest rates rise. So I put some of the rules there at the bottom. You can see the value of a European call option is directly related to fixed risk-free interest rate. So the call option increases as interest rates rise. B, a put option increases as volatility decreases. No. The value of both the European call and a put is directly related to the volatility of the underlying. So as volatility increases, prices increase. As volatility decreases, prices decrease. So B is wrong. And finally, put option decreases as interest rates decline. No, the value of European put is the put is inversely related to the risk-free rate. So as interest rates decline, the put option would increase. So again, need to memorize all these rules. So one last practice question, and I think you see you should be getting the hang of these by now. So if the volatility of returns of an underlying security increases, then A, both call and put option prices increase. B, both call and put option prices decrease. Or C, call prices increase and put prices decrease. Okay, by now I think you should be smiling and saying these questions are getting a lot easier. So if the volatility of returns of an underlying security increases, then A is correct. Both the call and put option prices increase. So remember, I copied and pasted from the previous slide, the value of European call is directly related to the volatility of the underlying, and the value of European put is also directly related to the volatility of the underlying. So A is correct because higher volatility increases the possible upside value of the underlying, which increases the price of calls and does not hurt puts. Higher volatility also increases the possible downside value of the underlying, which increases the price of puts and does not hurt calls. So a very nice practice question. So one last slide on pricing and valuation of options here, and it's with regards to the effect of payments on the underlying and the cost of carry. So a European call option is worth less the more benefits that are paid by the underlying, and worth more the more costs that are incurred in holding the underlying. A European put option is worth more the more benefits that are paid by the underlying, and worth less the more costs that are incurred in holding the underlying. Okay, so both the European call option and the put option is worth more the more benefits that are paid. But we've got a difference here, and that's good material for exam questions, is that with regards to a European call option, they're worth more the more costs that are incurred, but with a European put option, they're worth less the more costs that are incurred. Okay, now with that, that's the last slide for this LOS.